Okay, let's get started. This is Knowledge Maps Spring 2019. This is Daniel here doing my quarterly check-in and quarterly update and updating everyone on what I worked on this quarter. So let's get started. So we'll start with what is Knowledge Maps. So a little bit of context here. Knowledge Map caters to the advanced beginner web developer demographic. And we define an advanced beginner web developer as someone who understands overarching CSS concepts and syntax, but are not yet capable of employing the professional practices used by professional software engineers. So you can think about it as someone who's really trying to better their skills to a professional degree. And the goals of knowledge maps is that we're trying to get users to understand the visual outcomes, code, and practices, which we'll term as approaches for the rest of this presentation, within individual professional examples. This is achieved in conjunction with existing projects such as Ply and scaffolded exercises within the Railsig as well, and is focused on individual understanding of examples. Knowledge Map's main goal is to have users understand that examples with similar visual output, these are examples that kind of look alike on the web page or web browser, can be implemented with different approaches and different techniques in terms of code. And likewise, it also wants users to understand that examples with varying visual output, so that the examples that might look similarly different, can be implemented with similar approaches or similar code. And the overarching goal is to have users develop a rationale behind each approach, and by comparing and contrasting with different approaches, understand when an approach can be applied for their own use cases. So current related work, I've broken down into internal and external. Internal referring to projects that are currently or have been done within the scope of our research. So we have projects Apply, Telescope, and Scaffolded exercises, which, as I mentioned earlier, are very effective at scaffolding novices to sense make and replicate professional code for individual examples. And this addresses the first and second steps to becoming a professional web developer, but not the step past that of being able to apply your knowledge onto new examples. W3 Schools and Codecademy are external websites that seem to present themselves as platforms where you can learn how to code, and it's effective at scaffolding novices to understand individual examples by way of live interaction with code. So the idea is you're able to edit code rapidly and get rapid feedback, as you can see in the browser on the right. Now, the drawback of that is that typical examples presented in Codecademy and W3 Schools tend to be very constrained because they aim to cover breadth over depth, and as a result, they lead to a shallow level of user understanding. So the key question is, how can we scaffold advanced beginner web developers that I described earlier to identify professional approaches from professional examples in future contexts? And the conceptual approach to that is we want to be able to design a platform which scaffolds users to compare professional examples and the underlying source code beneath it, create conceptual maps, hence the term knowledge maps, of their understanding, and apply this understanding to future contexts where applicable. So a summary of my contributions this quarter were broken into two major deliverables. So being my first quarter back on this project from a 2-quarter break, I started up by ramping up on existing work and understanding the existing prototypes. So this is the second point there. And what I was able to do was to understand the existing design arguments, to be able to articulate it in my own words, and to identify risk between those design arguments. And what that led me to do is I tackled a pretty major risk within one of the design arguments, in that we didn't have a good way to measure user understanding across a knowledge map based on user justifications. So I went about refining the measurements for user understanding. And this started by identifying the outcomes and what we want users to understand. So kind of like thinking from the end of the whole knowledge maps process. Segmenting out the understanding and the outcomes into different layers. For example, C and F. And we slice that because examples C and F are one set of examples. They're both grid, CSS grid examples. And what that allowed us to do is to focus on individual user understanding with regards to just that group of examples. I went about reasoning obstacles to reach the outcome, and the outcome is the different layers of user understanding, and identify potential characteristics that could contribute to the outcome, which sits in future work. Finally, once I came up with the refined measurements, I ran the prototype with the refined measurements by designing and conducting a new study, synthesizing user takeaways, and then finally revising my interface system and design arguments. So without further ado, let's go through it. So let's go through design arguments and interface and system model first. So most of this is relatively familiar from the past quarter because the prototype characteristics haven't been changed too much. The first design argument refers to code highlighting. We provide code highlighting to help identify lines of code that contribute to a common CSS implementation approach. And we do this without over-scaffolding and revealing the approach to the example. So we don't want to tell users to answer. And the obstacle to this is we're shifting the user to save them the time of finding similar code and allowing them to focus more on conceptual similarity across examples. The second design argument is we provide articulation prompts to help users gain a surface level and deeper level understanding of the differences and similarities of the examples by considering the approach behind each one. And the obstacle behind that we're trying to overcome is that previously users would identify only shallow surface level differences across two examples. They might say that visually the items might be laid out differently, or that code-wise there might be a different attribute, but that's very shallow level and not quite the outcome that we're looking for. We want users to gain a deeper level understanding and be able to build a rationale behind each approach. So this is an interface model showing the code highlighting component here. So we were originally paper prototyping, and as you can see between the two examples, you have C and F, which are the grid examples, which I'll digitally display later for future reference. And blue represents that we have an attribute, we have the same property, whereas yellow represents that we have the same property as well as the same attribute supplied to that property. So you can see that we do that to highlight and allow the users to more readily identify the similar lines of code. Articulation prompts have been kept mostly the same for the purpose of figuring out and testing the current prototype. So we are generally presented with a question. In this case, it's applicable to example C and example F with regards to grid template columns attribute. And previously, we used to have the answer where we would check off the differences across the examples based on what the user would articulate. But there's a new measurement that, as I mentioned earlier, I came to implement this quarter. So we'll be going over that, but this is the articulation prompt at a high level. Also, we understand that users are not able to immediately understand all of the code that's provided to them, and in order to have them overcome that obstacle, we provide supplemental documentation, mostly through the form of Mozilla Developer Network, which in this case, the sample documentation is for the grid template columns property. So we'll go through the user testing and study process. So study setup and methodology is based on the current process for running the current prototype. Primarily that users are briefed that they're trying to understand professional examples and encouraged to articulate their thought process. In this case, as I mentioned earlier, we sliced just on the grid examples, so users are just provided examples C and F together with the code highlighting characteristic, as I demonstrated earlier. And what I did differently this time is that users are encouraged to render the example online. I'm going to go through that later, but essentially there are certain interactions that the user has to make to be able to discover certain visual output. And once the users have been able to look at the examples, they're given the articulation prompt, which I highlighted earlier and we'll go through. And the user articulation prompt is analyzed, and understanding is measured based on the observations they make that match up with the ones that we want to figure out to what extent are users able to understand the individual examples, as well as develop a rationale and compare and contrast across the multiple examples. So in other words, with the refined measurements, how much or how far are users able to get with regards to the current characteristics, and why might that be? So I broke down my measurements into 4 primary layers of understanding. It starts off at individual examples and then progresses to comparison across examples. So the first one is visual outcome and visual feature. And what a visual outcome and a visual feature is that you basically make an observation about the visual output of a particular example. So in this case, I pulled up example C. This is the grid example here. And you can see that we have 3 columns here, and when we initiate columns that are displayed on the screen of equal width. The next layer of understanding that we anticipate users to be able to get to is the code responsible for the visual outcome. So in this case, I pulled up the paper prototype of example C. This is a digital rendering of the paper prototype. And we can see here that in order to display the 3 columns, we have to have 3 instances of the 3 parameters passed into the grid template columns property. So, and we can see here from the media query as well. And you would learn, typical user will learn this through reading documentation about media query and grid template columns, that at a minimum width of 60 units, there are 3 columns that are displayed within the blog feed wrapper. So that's the code understanding directly corresponding to the visual outcome that I identified earlier. Cool. So the next layer of understanding is we want to, so in the case of example C then, the approach that I would ideally want users to be able to say is that by using media queries, which dynamically change the CSS based on, in this case, the condition minimum width, we're able to manipulate the number of columns that's being displayed via the grid template columns property. And we do that by supplying a different number of parameters within the grid template columns property, so a different number of attributes, I should say. And in this particular case, what I would argue that the approach is that we're using the media queries to dynamically set and hardcode the number of columns, and that the rationale for this is that we want 3 columns past a certain width, regardless to how big the window is going to be. And we also want 1 column no matter how small the window is. So in this particular case, we have a small number of columns, and it's appropriate that we know when to display how many columns. So as a result, that's the rationale and the approach for example C. Finally, we want users to be able to understand the application and when to use which approach. So I pulled up example C, and I'm also going to pull up example F here. A quick summary of example F is that example F here uses grid template columns once, and they use that repeat property and the autofill min-max. So it's kind of a complex query here, but basically the general idea is you're repeating a bunch of these icons here on the left for as much as the parent container affords it. And whereas in example C, you're directly hard coding the number of columns that are displayed, whereas in example F, you're coding as many columns as possible within the given range, given a consistent item width of at least 9 REM and at most 1 fractional unit. So the idea here is that you want to use example C when you have a smaller number of columns and when you want more control over how many columns to display at a particular view or window size. And in example F, you want to, since you're displaying as many consistent items as possible, it's more appropriate when you're displaying more items that are consistent in nature and you're just trying to display as many as possible. So the core findings from the approach is that we took the 4 layers of understanding for both example C and example F, so both individual and both across examples, and we assessed how far the characteristics allow the users to affordances and characteristics. Users are not making certain visual interactions with examples necessary to discovering certain visual output. So let me go over why this is the case. So in example C, you can see here that we have the 3 columns here. And when users pulled up the example, there was no explicit scaffold to tell them to resize the example. And what happened as a result is that users would have a tendency to look at the code and speculate. In this case, some of them would say that, I think there will be 2 columns when we have a minimum width. And then finally, when because I didn't want them to guess, I told them explicitly to consider what will happen if you try resizing the window. So in this case, users were not able to fully discover the visual output before making speculation at the code level. And that was a risk because they were essentially speculating instead of building on existing understanding. So this is for individual examples. Finding number 2 is that with the current articulation prompt, users are able to identify the approach behind examples C and F, but are not able to provide a strong rationale for when to use which approach. So this goes off the question where despite users knowing that example C is using media queries to code in a fixed number of approaches for a certain width, and example F repeating as many as possible dynamically, one participants still have like a relatively low level explanation when they're being asked the question of when to use which. And in this case, one participant said that you just use media queries when you have specific window widths and requirements and less columns. And you use repeat when you have more columns you want to display. And while that at a high level has some validity, it doesn't really cover the nuances between the two approaches and the deeper level of when to use which and why you would use one over the other. Finding number 3 is that with the current articulation prompt, users are able to identify the specific code responsible behind the visual outcomes for both examples C and F. Part of this is that the articulation prompt prompts the user to focus a lot more on the code than the visual output. So one participant successfully identified, at least in more generally, that media queries control how many columns to display to the screen for a given width, for example, C. He obviously went into detail to tell me how many displayed at any given width, but the idea here is that because the articulation prompt was so code-centric, users had no problem understanding the code and taking it from documentation if they didn't. Finding number 4 is a little bit more convoluted, but it's while our outcome, which is user knowledge, is now highly structured, that we broke it down into the 4 levels, from individual understanding to applied understanding across examples. The articulation prompt, where it points out a difference between the 2 examples and asks the user to explain it, does not provide enough structure to guide the users to reach the outcomes that we have now, the structured outcomes, especially with regards to rationale and comparing across examples. So in both instances, users focused on code level approach a lot, so they would start with the code, and they didn't really focus too much on visual output. And part of it is that we didn't have the characteristics to support users to fully identify all the visual outputs, but they use visual output more so as a way to check their understanding for individual examples. So had I not told them about the visual output or the interaction, they would have probably just speculated what the visual output might look like. And the users consider rationale and application, so applying the approaches at a very general level, because they were simply asked to explain the difference and when you would use one over the other. So there isn't too much in-depth explanation into why you would use one over the other, just simply when you would use one over the other. And there isn't too much application, right, in situations where we talk about, okay, what's a situation where you would use example C over F or F over C, and likewise. So there's not enough depth in the application of the approaches for the user's knowledge. So some discussion, next steps. So if our outcome or intended user takeaways is highly structured now, and users are providing unstructured answers with the current affordances, notably the articulation prompt, I believe we should add characteristics which support structured thinking for our users. And the benefit for that is that it allows for kind of a systematic transition to build a user's understanding. So you can start with a visual interaction and provide affordances for the user to see all of the different states. And that'll prompt the user to wonder what in the code is responsible for that interaction and what is responsible for that visual output. And finally, once they understand it for all the visual cases, come to a rationale of why the approach was taken for the particular example. That said, I want to add an interface augment feature to scaffold the user into making the interactions on digital renditions of the example. Otherwise, they'll miss out on the visual output. As for what I want to do next, there are quite a few things I want to do, but I'll run through them. So the first one is I want to update and test new characteristics, which guide the user's thinking towards our outcomes. The design argument will be tested by way of the new measurements we introduced this quarter. And primarily, we would devise a set of characteristics and measure it using the measurements that we have devised and see how much better the users are able to do with regards to the metric. I want to implement a digital prototype that kind of carried over from this quarter that allows for one to easily pull up and compare professional examples. I think we've come to a conclusion here that paper prototyping has its uses, but in the specific case where we want users to make visual interactions or digital interactions, paper prototype doesn't have that affordance anymore. And part of that will involve me integrating with Ply, which is something that I have to look into on the tech end. And if the new set of characteristics and measurements prove to be promising, we can definitely apply the same 4-tiered understanding and measurement to flex examples as well as positioning examples, which would give us a full example set of A through G, not just C and F. Key takeaways is that the reflection and articulation prompts have to be careful of over-scaffolding users into giving them the answers. One thing that I think is a risk is that since we do point out which lines of code to focus on, we are kind of giving, in our articulation prompt, we are kind of telling the user what code is part of the particular approach. which in some examples, we're not sure if the user would have actually discovered that on their own. And another thing is, in order to attain a structured representation of user understanding, we'll have to devise a structured set of characteristics. So what the purpose of this is I think we can come up with a process that kind of walks the user through each layer of understanding and finally have that contribute to the final outcome, which is their holistic understanding and deeper level understanding of the approach. Some key implications is that the measurements I worked on this quarter can progress from one set of examples to another. The measurements that I worked on to devise can be applied to a broader range of examples, ideally, but that's a little bit more down the road once we can apply to the current examples. And the future features and characteristics, including scaffolded questions and articulation prompts, can be automated, and that's something that we can consider as we test and get more promising results and decide to move more of this into the technology space and think more about interface and system arguments. I believe that concludes. Yep, that concludes my run through, and I hope this summarizes all of my work for this quarter. Thanks.